Hey everyone, how you doing? Hope you're doing well. I'm Nudger, welcome back to the channel. Now today I've got another video for you concerning nuclear weapons. I did one the other day, and this one's going to be a bit more informative, because what we're going to be doing is we are watching these VFX artists, so they're special effects artists, and they reveal the true scale of just how big and how much damage a nuclear explosion can be. And for anyone that's in America, they're doing this over Los Angeles. So at least that way you can get to scale on how big this explanation is. Now, if you're not already subscribed, my first question, why not? Go down, thumbs up, subscribe and share it. You know, because that's how I can grow my channel, by you guys doing those three things. Right, that out of the way, let's move along to the corridor crew, guys. Let me full screen. Let's see how bad this actually is.
This is downtown Los Angeles, and I'm gonna blow it up with a nuclear bomb. Okay, not actually, that would be too expensive, but I am gonna use visual effects to show you what that would look like. You are very familiar with nuclear weapons. I mean, they're depicted in movies all the time. However, they never do a good job of showing what actually happens during a nuclear explosion. I mean, this movie would have you believe that you could survive a nuke just by getting in your fridge.
That's not how the Force works.
Even when we look at real test footage, it's still difficult to truly understand the power that's on display. They're always in these desolate, remote locations with nothing nearby to visually compare their size to.
It's still
this test in the
scary.
ocean had battleships for scale. On their own, it's just really hard to grasp the true magnitude of these explosions. Take a look at this shot. If you saw the movie Oppenheimer, then you're already familiar with the first test of a nuclear bomb, Trinity. Sure, it seems powerful, but it's not until I put the 900-foot tall Eiffel Tower next to it that you can begin to grasp its true scale. Now, imagine instead of blowing up this bomb in the desert, it actually blew up in downtown Los Angeles. Well, you don't have to imagine this.
5, 4, 3, 2, 1.
Oh, trust, we'll come back to this in a moment, so stay tuned.
I mean, obviously these are special effects experts, these guys, you know, and they really know their stuff. So it's interesting so far. Let me just see what he's got to say.
I just wanted to give you some context first, because let's be honest, this is kind of weird. It's hard for me to make a video in my upbeat tone about weapons of mass destruction. So I'm going to focus on the science behind the explosion itself, because that is truly mind-blowing.
Yeah.
Explosions are actually pretty simple. They're just huge releases of energy over a short amount of time. Now, the vast majority of explosions are the result of chemical reactions, such as the gunpowder that fires bullets, or military explosives that use TNT.
'Cause I'm TNT, I'm dynamite, TNT, and I'll win that fight!
Okay, quick clarification about TNT and dynamite, because a lot of people seem to think that they're the same thing, but they're not. Dynamite is solidified nitroglycerin, which is very unstable and dangerous.
This is not the way you transport nitro...
On the other hand, TNT, or trinitrotoluene, is so safe and shock resistant that it took 30 years for people to even figure out that it could explode. People used to use it to, like, dye their clothes yellow. I'm not kidding. These days, however, TNT is one of the most commonly used explosive chemicals in the world, used for everything from geological surveys to hand grenades. Did you know that hand grenades just have TNT inside of them? Because I didn't. I mean, I do now.
Same as me.
Nuclear bombs, however, just hit different. In movies, you can always tell it's a nuke because there's a mushroom cloud. It's a very distinctive shape. However, this shape isn't actually exclusive to nukes. Mushroom clouds occur from any sufficiently large explosion. It's just how thermals work in the air. In fact, the first documented example of a mushroom cloud is from the 1700s. So how do nukes hit different? Instead of a chemical reaction, it is a nuclear reaction. And thanks to this dude who had special relatives, we have the equation E equals mc squared, which basically just means that energy is the same thing as mass. Stuff can be converted into pure energy, and pure energy can be converted back into stuff. So in a nuclear explosion, stuff like uranium ascends beyond its three-dimensional form to become pure energy. And it is a lot a lot of energy. Yeah, so notice that little c squared from the equation? That stands for the speed of light times the speed of light.
Yeah.
So energy
second
is
per second.
actually equal to the mass of something times 90 quadrillion. You don't need a lot of mass to equal a lot of energy. For example, a single drop of water has a mass of 0.05 grams. It's a tiny, minuscule amount of water. But even converting just this much mass into energy would yield an explosion as large as the one we saw in Beirut.
I was waiting for an advert, but so far, it's quite interesting so far. So let's carry on.
20.
Ooh.
This tragic accident was one of the most powerful non-nuclear blasts in
Look at
history.
that.
It had enough concussive force to shake the entire country of Lebanon, and yet it was still only a 20th the size of the Trinity test. While the Beirut explosion was caused by a warehouse full of ammonium nitrate, Trinity was fueled by a core of plutonium just the size of a bowling ball. Nukes release so much energy that a new unit of measurement had to be formed. 2 months before Oppenheimer detonated the gadget, they blew up 100 tons of TNT, or 0.1 kilotons. This explosion was literally humanity making a big mark in the earth and going, yep, that's my measuring stick now. And this is how physicists were able to figure out that the size of the Trinity explosion was the equivalent of 21,000 tons of TNT, or 21 kilotons. But here's something crazy. In 2021, they actually reanalyzed the data and determined that the actual yield of this explosion was 25 kilotons. So, yeah, as if that distinction even matters when you're blowing up a city. Speaking of which...
5, 4, 3, 2, 1.
Look how scary that is, guys.
In the first 1/1,000,000th of a second after nuclear detonation, the heat is already so extreme that a ball of plasma forms. It's a fireball so hot, it reduces everything inside it to subatomic particles. The core of our star is 15 million degrees Celsius, making it the hottest point in the entire solar system. But for a brief moment in time, it becomes the second hottest point because the core of a nuclear fireball can reach 100 million degrees. To put that in perspective, that's 20,000 times hotter than the vaporization point of diamond, one of the most resilient materials in the entire universe. So it doesn't matter if you're in a fridge or a bunker made of diamond, if you're inside of this fireball, you will get deleted from existence. All of this heat radiates outward at the speed of light, instantly scorching anything unfortunate enough to be within view. This real test footage shows the paint getting vaporized at the moment of detonation. It's quite literally a laser engraver, but like everywhere. Anything combustible immediately ignites on fire, including everything within a mile of this explosion. All the people within a mile and a half would receive third-degree burns. It's a burn so bad you don't even feel it. And looking at this test footage, what I find fascinating is that it's not actually windy. What we're seeing is the heat of the nuke pushing the smoke away like it's the solar wind or something. It's just that intense. The real wind and the most devastation is still to come. The shockwave is a sphere of high-pressure air that expands outward faster than the speed of sound. In fact, this shockwave is so powerful, it levels up into something even deadlier. When it hits the ground, it reflects back up to recombine with itself, forming what's called a Mach stem. It gives the shockwave a razor's edge, shaving the city down to rubble. It's been a few seconds at this point, but the explosion is still happening! The shockwave leaves behind a pressure vacuum which sucks all the air back in with hurricane-force winds. It's not as strong as the initial...
It's exactly what I said on the last video I showed you about the nuclear explosions. Sorry, how it goes out, then it comes back, and when it comes back, it will just take everyone that's still standing and most things up with it. So you're going up into that mushroom cloud, guys, regardless whether you're still alive or not.
Shockwave, but this is more insidious. As the air rushes back into the city, it delivers fresh oxygen to all the fire! The rushing air feeds the flames, which create fire tornadoes that swell to hundreds of feet high. This terrifying reality is called a firestorm and is exactly what happened to Hiroshima. It was a city made almost entirely of wood.
Sadly for them.
Yeah, that got kind of real. I wanted to show you a hypothetical explosion so that we could separate the physics of nukes from the lives they've taken. But I don't think I can do that. Separating the science from the deaths?
No.
It's impossible. Nukes are not fun. They're weapons of war, and the devastation they've caused isn't something we should ever ignore or ever forget. Especially because this one was a small nuke. World War II may have ended, but the Cold War had just begun. It was an arms race between America and Russia to build bigger and bigger bombs, such as the B-83. It's the most powerful nuke in America's arsenal right now, and yet physically, it's not that big. It's 12 feet long. In fact, the warhead itself is just right up here at the front. For something so small, how powerful could it be?
B-83.
1,200 kilotons. Yeah, this is a megaton bomb. I'm using a tool called Nuke Maps. If you just Google search Nuke Maps, you'll find this. Just plug in the warhead yield of your choice, whether or not it's detonating on the surface or if it's an airburst, and then you just hit detonate.
Boom.
This is the fireball, this is the strongest part of the shockwave, and this signifies where everyone gets third-degree burns. This is what the Trinity explosion would look like in downtown LA, but if I put in the B-83 of 1,200 kilotons, that detonation would look like this. It's like almost 2 miles wide, just the fireball. Now, the B-83 is just the most powerful nuke that we currently have in our arsenal. We've tested many more powerful nukes. For instance, the Russians tested the Tsar Bomba, which was a 50 megaton bomb. And this would literally destroy the entirety of Los Angeles.
LA gone. How mad is that? The entirety of LA gone.
I just turned on the casualties. Estimated casualties are about 3 million people.
That's the least.
Instantly. I think there's a good reason why people don't normally think about this stuff.
Yeah. There's a reason why.
Going back to the B-83, yes, this is smaller, but we built 650. There are 650 of these things just out there in the world somewhere. That is enough to scorch every single square inch of California.
Crazy to think, isn't it?
Are you scared yet? I am. We don't need 650 of these bombs. I mean, whether or not we need them at all is a separate conversation, but 650? I think we can all agree that is too many. Mutually assured destruction is still assured destruction, but thankfully there is hope. Both the US and Russia have reduced their nuclear stockpile by 50,000 warheads since the height of the Cold War. Think about that for a moment. Two nations with a history of animosity and distrust were able to set aside their fear of each other and put most of their weapons down. When I see that, I don't see a species trying to destroy themselves. I see a species with a reason to save themselves. And that gives me hope.
Yeah.
We need more of that for the safety of us all. But thanks for watching.
Well, guys, I don't know about you, but I think he sums it up very well, don't you? He went into the math and the science. He gave descriptions on the nuke maps of just how devastating each nuke can be. You know, it is absolutely ridiculous. So, let me just, there we go, leave that there. It's mind-boggling and scary to think, you know, that this, I mean, touch wood, it won't happen, you know, but there's always like a scenario where it could. So, yeah. I'm going to leave that with you. Like I said at the beginning, guys, if you enjoyed this, like and subscribe, you know, and I'll see yous on the next video. Catch you later.